Hi everyone, Mr. Markwick here. In today's video, I'm going to show you how to calculate quantiles in regards to normally distributed data. And again, I'll be showing you how to do that on the graphics calculator. Before I get into an example here, I'm just going to run through this introduction, which tells us a little bit or helps us understand a little bit about what quantiles actually are. It says here, consider a population of crabs where the length of the shell, X millimeters, is normally distributed with a mean of 70 millimeters and a standard deviation of 10 millimeters. Now we know that the mean and the standard deviation set the parameters of that normal distribution curve for us, so that the mean will be the middle value, okay, and each standard deviation step away, we are either taking away that standard deviation value or adding that standard deviation value if we move to the right of that mean. Anyway, hopefully you know a little bit about that. It says here, a biologist wants to protect the population by allowing only the largest 5% of crabs to be harvested. He therefore asked the question, 95% of the crabs have a length less than what? And if you have a length less than that value, then you'll be a protected crab. If you have a length greater than that value, then you will be allowed to be harvested, okay, essentially. To answer this question, we need to find K, the quantile, such that P, the probability of X is less than or equal to K, is equal to 0.95. Now, I could rewrite that same equation to talk about basically 5% of crabs have lengths greater than what? So P, probability of X being greater than or equal to use the variable A, is equal to 0.05. So you can reword that sentence there. Instead of saying 95% of crabs have lengths less than what, this this blue equation could be read as 5% of crabs have lengths greater than what? Okay, and it should be the same value. Well, it will be the same value. And I'll show you how to do that using the graphics calculator. Both of these, I guess, sort of examples, even though that's only giving me one, because there is a slight difference if you're using the less than or the greater than symbol here. So the number K is known as a quantile. In this case, it's the 95th percent quantile. All right, so let's look at the example that we're given here. It says X is normally distributed with a mean of 23.6 and a standard deviation of 3.1. Before I even read the next sentence, I'm actually going to show that here on this normal distribution curve. So the mean is 23.6. That's the value here in the middle. So 23.6 is the mean of the data. It's normally distributed. So every standard deviation step up, I'm going to increase that by 3. So this becomes 26.7. You can see that I've just added 3.1. Okay, I've added the standard deviation. Now I'm going to do that again to become another 2 steps away. It will be 29.8. Okay, again, you can see that I've just added 3.1. And again, the next step up, the third step up from the mean, will be 32.9. On the way down, obviously, I'm going to subtract that standard deviation. So 23.6, subtract that standard deviation of 3.1, will give me 20.5, subtract 3.1 again, will give me 17.4, subtract 3.1 again, will give me 14.3. So there it is, my normal distribution curve has the values filled in down the bottom here. The question then goes on to say, find K for which the probability of X is less, probability that X is less than K is equal to 0.95. So if you know a little bit about your normal distribution curve, what we're actually talking about here is we're talking about this section around about here approximately. What is that value going to be? Okay, and I'm talking about the 95% of this data. Okay, so I'm talking about this red section here is the 95%. Now, like I said, if you know a little bit about it, that's where sort of the 95% will fall approximately in between, one standard deviation above and less than 2 standard deviations above. Okay. Now that sort of information I've got from here. Okay. And we've looked at this before. So if you add up this area plus this area plus this area, okay? And if you add that, that takes you over 95%, okay, that last one. So it's kind of in here somewhere, right? But whereabouts exactly in terms of a numerical value does it fall? We know it's between 26.7 and 29.8, but what is the exact value? This is where we use our graphics calculator. So if you open your graphics calculator up, head into the stats function there, and again, we're looking at distribution, so F5, normal distribution, so F1, and now we're going to be using the inverse of normal distribution, so F3 here. Again, you need to set, rather than the list, set it to a variable, which then allows you to put in your parameters. So for example, the mean of 23.6, okay, which was given to us in the question, the standard deviation of 3.1, which again was given to us in the question. The area we're talking about here is 0.95, okay, or 95% of that data. So go ahead and put in 0.95, okay. Obviously that value has to be less than 1. So if it's a percentage, convert it to a decimal, okay, just like we do for that those probability questions. Now, the tail. Am I using the left, right, or central tail? I use the left tail if it's a less than symbol. Okay, so I want my tail on the left if it's a less than symbol. If it's a greater than symbol, we're going to use the right tail. So because this question here has probability x is less than k equals 0.95, we are using the tail left. Okay, so go ahead and scroll down and press calculate, and it will tell me that this value here is 28 point, let's round it to one decimal place, 28.7. Okay, so k equals 28.7. Now again, I could rewrite this, equation so that I write it like this: probability of x being greater than, again, let's say a is equal to 0.05. Okay, so now what I'm going to do is go back into my graphics calculator. I already have the mean and standard deviation set, so I'm not going to change those values. I am going to change the area from 0.95 to 0.05, so we're talking about 5%. And I'm now going to change the tail from left to right. So now I'm talking about this section here. Okay, but it should still give me this same value here that we just worked out before. That's the process. If you're given a greater than symbol, your tail will be on the right. Okay, so just go back down and hit execute there. And again, it gives you the same value, the exact same value. So in this case, A is equal to 28.7. Okay, so that's just a quick introduction into quantiles, what they are, and how to calculate them using the graphics calculator. Hopefully it helps, and hopefully that made sense. Thanks for watching.